Something does not add up. Right now, 400 billion stars burn in this galaxy. Around them orbit trillions of planets. Billions of those planets sit in habitable zones, where liquid water could exist on the surface. The universe has been running for nearly 14 billion years. Our galaxy alone is old enough for a civilization to have colonized every star system in it, even at speeds far below the speed of light, multiple times over. The math has been done. At just 1% of light speed, with self-replicating probes, you could visit every star in the Milky Way in roughly 10 million years. That sounds like a long time. It is not. The galaxy has been here for over 13 billion years. 10 million is a rounding error. Any civilization with a few million-year head start could have been everywhere by now. And yet, when we point our telescopes at the sky, when we scan every frequency, when we listen with instruments sensitive enough to detect a cell phone signal from Jupiter, we hear nothing. Silence. Not ambiguous silence. Not "we haven't looked hard enough" silence. Measurable, documented, 63 years of searching silence. That silence has a name. The Fermi Paradox. Named after physicist Enrico Fermi, who reportedly asked the question over lunch at Los Alamos in 1950. His colleagues were discussing the probability of extraterrestrial life. Fermi listened, did some mental math, and asked a question that has haunted astrophysics ever since. Where is everybody? We have been dealing with the extremes of physics and the limits of human ambition. But this question makes all of that feel small. Because the Fermi Paradox is not a puzzle about aliens. It is a puzzle about us. Every proposed answer to it tells us something uncomfortable about the universe, about intelligence, or about our own future. There is no happy solution. There is no version of this where the answer is reassuring. Every door leads to bad news. The only question is, which flavor of bad news you prefer. The first door is called the Great Filter. It was proposed by economist Robin Hanson in 1998, and the idea is this. Somewhere between dead chemistry and a galaxy-spanning civilization, there is a barrier so difficult that almost no species gets past it. A filter. Something that kills the process before it reaches the finish line. The question is where the filter sits. If it is behind us, in our past, then we are extraordinarily lucky. Consider the steps. A planet must form in a habitable zone. Chemistry must become biology. Single cells must become multicellular organisms. Multicellular organisms must develop complex nervous systems. Complex nervous systems must produce intelligence. Intelligence must produce technology. Technology must produce communication. Each of those steps could be the filter. Each of those steps could be so improbable that it happens once per galaxy, or once per universe. There is some evidence for this. Life on Earth appeared almost immediately after conditions allowed it, roughly 3.8 billion years ago. But multicellular life took another 2 billion years. The jump from simple cells to complex organisms appears to be extraordinarily difficult. If that transition is the filter, then we have already passed through it, and the silence makes sense because almost nobody else made it this far. But if the filter is ahead of us, then the silence means something worse. It means that civilizations like ours, civilizations that build radio telescopes and worry about the future, regularly fail. They reach a certain point, and then they stop. They destroy themselves, or they are destroyed, or they transform into something that no longer communicates. And the silence is not an absence of neighbors. It is a graveyard. The Fermi Paradox assumes we would recognize a signal if one arrived. That assumption itself might be the problem. But even accounting that, the scale of the silence is difficult to explain away. The second door is stranger. The zoo hypothesis, proposed by MIT radio astronomer John Ball in 1973, suggests that advanced civilizations are aware of us and have made a deliberate choice not to make contact. We are being observed. The silence is intentional. This sounds like science fiction, and in many ways it is unfalsifiable, which makes it unsatisfying as a scientific hypothesis. But the logic is internally consistent. If a civilization is millions of years old, its understanding of biology, ecology, and the development of intelligence would be so far beyond ours that it might view contact the way a marine biologist views a coral reef. You study it. You do not introduce yourself to it. You especially do not hand it technology it is not ready for. The analogy extends further than you might expect. We have uncontacted tribes on Earth right now, peoples in the Amazon and the Andaman Islands who have never interacted with modern civilization. And the general consensus among anthropologists is, leave them alone. Contact does more harm than good. If that is our own policy toward less technologically advanced humans, imagine how a million-year-old civilization would view us. The uncomfortable part is not the idea that we are being watched. The uncomfortable part is the implication that contact is being withheld because we have not earned it, that there is a threshold we have not crossed, and that the civilizations who crossed it looked at us and decided to wait. The third door is the darkest. It comes from physicist and science fiction author Liu Cixin, who formalized it in his novel The Three-Body Problem, the dark forest hypothesis. The idea is this: the universe is full of life, intelligent life, technological life. And every civilization that reaches a certain level of capability arrives at the same conclusion. The safest strategy is to stay silent, because any signal you send reveals your location. And any civilization that detects your signal faces a choice: make contact, which is risky, or eliminate the potential threat, which is safe. In a universe of unknown intentions and limited information, silence is the optimal survival strategy. The math behind this is game theory. Specifically, it resembles a cosmic prisoner's dilemma, with no way to verify the other player's intentions. If you assume the worst, hiding is rational. If you assume the best, you might be wrong. Exactly once. The dark forest says that the universe is not empty. It is full of civilizations hiding from each other in the dark. And anyone who makes noise gets eliminated. This is, to be clear, a hypothesis, not a fact, not even a widely accepted theory among most astrophysicists. But it is mathematically coherent, and it has an uncomfortable implication for us specifically, because we have not been quiet. We have been broadcasting radio signals for over a century. Television, radar, military communications, deliberate SETI transmissions. Our electromagnetic footprint extends roughly 100 light-years in every direction, growing at the speed of light. If the dark forest is real, we have been standing in the woods with a flashlight, shouting. That reframes the silence from a mystery into a warning. The fourth door is the one closest to home: self-destruction. Not through cosmic catastrophe or alien intervention, through the ordinary, predictable mechanics of a civilization consuming itself. Climate collapse, nuclear war, engineered pandemics, resource exhaustion, artificial intelligence that optimizes for the wrong objective. The argument is statistical. If the average technological civilization survives for 10,000 years after developing radio, and the galaxy is 14 billion years old, then the window of overlap between any two civilizations is vanishingly small. Most civilizations are already dead by the time their nearest neighbor starts listening. In 1961, Frank Drake wrote an equation to estimate the number of detectable civilizations in the galaxy. Every variable in that equation is uncertain except one: L, the average lifespan of a communicating civilization. And L dominates the result. If L is 1,000,000 years, the galaxy is crowded. If L is 1,000 years, we are alone. The entire Fermi Paradox, the entire question of cosmic silence, may reduce to a single variable. How long does a civilization last after it discovers how to destroy itself? We have exactly one data point for that question: us. And our track record is not encouraging. We have had nuclear weapons for 80 years. We have come within minutes of using them at least twice. We have had the ability to alter our own climate for roughly a century, and we have done so without a plan. We have not destroyed ourselves yet, but an outside observer reviewing the data would not place a confident bet on our next 1,000 years. The math does not lie. Here is what ties all four doors together. They are not competing answers. They are competing nightmares. If the filter is behind us, we are rare and profoundly alone in a universe built for company. If it is ahead of us, we are walking towards something that has killed every civilization before ours. If they are watching, we are being judged by standards we cannot see. If they are hiding, the universe is a dangerous place, and we have already made noise. And if civilizations simply do not last, then the silence is not a mystery at all. It is a forecast. A weather report from the future, written in the data of every dead civilization that came before us and left no trace. Axiom does not pick sides, but the universe already did. There is no version of this question where the answer is comfortable. There is no door you open and find reassurance behind it. The Fermi Paradox is not waiting for a solution. It is waiting for us to understand the question. And the question has never been, where is everybody? The question is, why does nobody survive long enough for us to hear them? That is not an astronomy question. That is a mirror. And what it reflects depends entirely on what we do next, as a species, in the next few hundred years. The universe is watching. Or it is empty. Or it is hiding. None of those options let you sleep easily. The universe did not ask for your opinion. And yet, here you are, thinking about it. And somewhere in that silence, 40 light-years away, there is a system with 7 rocky planets orbiting a dim red star. Some of them sit in the habitable zone. From the surface of one, you could look up and see the others hanging in the sky, closer than our own moon. If silence is the rule, this system is the exception that demands investigation. But that is a different kind of question, and it deserves its own answer.